Great. Well, thank you all. Happy to be here. As I mentioned, my name is Justin Manley. I am the president of the Marine Technology Society, and I am an ocean tech advisor and consultant for many years. And going to talk to you essentially about innovation and opportunities from my worldview in the Arctic. And basically, let's go next slide. Come on. Do it that way. Okay. In the presentation here, I'm going to address sort of two themes. One, I want to take some of the time and just introduce you to the Marine Technology Society, tell you a little bit about who we are and what we do, and then sort of change gears and dive into the specifics of just a small subset of specific technology thinking and ideas that might be applicable in the Arctic. And then really hoping to have a discussion around that more so than just sort of talking at you. So briefly, the Marine Technology Society, we are a classic scholarly professional society. So we look at ourselves as a convener and advisor on marine technology and innovation. We are global. But we are not a standard setting body. We're not a rules body. We're really more about helping individual practitioners. And we're also not an engineering society. So you may have heard of things like the American Society of Mechanical Engineers, where it sort of implies you need to be a mechanical engineer to be a member. We welcome anyone with an interest in the subject matter. You know, our primary goals here are to really help the world understand the fact that there is this thing called marine technology. It is a broad field. There's a lot of information to share. We promote and improve the technology through education and advisory programs. Talk a little bit about that when I talk about some of our committees, for example. And we're here to make sure that these tools are advanced in a useful and reasonable way. You know, and this is classic for folks, right? We have been around for a long time, and we're hoping that, you know, that history plus the strength of our network and our members is really there to help the public. As I mentioned, yeah, this is our 60th anniversary. So if you're sort of following LinkedIn, we're doing some highlights of, you know, essentially accomplished folks in marine technology, a little bit of history, but also a lot about today. And we're promoting awareness, and we're convening, right? And this last bullet about ocean engineers, technologists, policymakers, educators, students is really important. For us, marine technology is truly a diverse community, a large tent, to use a turn of phrase. And there are professionals that join as an individual human being. There are institutions, companies, labs, universities, government agencies that join as institutions or businesses. And wherever you fall in this spectrum of your role in the ocean tech, marine technology world, we welcome you. As I mentioned, we are global. We are North American strong. We were founded by essentially Americans. The drivers back at our founding, there were sort of two primary things going on. It was the emergence of offshore oil, right, was kind of coming to be. So some of our founding members were very interested in offshore energy. And then, for example, Dr. Alan Vine, who the DSC Alvin at Woods Hole is named for, was one of our founding members. And again, that was the early days of some more advanced ocean science and exploration and technology. Plus, of course, the Cold War was going on. So those were the kinds of things that led to our society coming together 60 years ago. Today, we are global. Total headcount of members, this does not include, we have a lot of student members. And historically, those numbers fluctuate a little bit, but you know, we can have several hundred more student members on any given day. But 1,800 so members, 80 different organizations, and you can see we're all around the world. I want to make a couple of quick remarks. So the Red Sea section recently came to be. Hosted at an organization called KAUST, King Abdullah University of Science and Technology in Saudi Arabia. Probably not a lot of Arctic relevance there, but I bring it up because I happened to visit there last year, about a year ago, August of last year, helped get that going. And I learned a lot about how a specific region, in this case, the Red Sea, and the Red Sea has very special oceanography. The temperatures are different. There's coral reefs there. It really was a focus point for them. And so they, launching a section for the people who are looking at that region and their particular marine technology needs totally made sense. So we're talking about Arctic. So there's a little bit of an analogy there. And there's a reason I point that one out. The other very recent one is Pacific Canada. And so it's in British Columbia. It's, individual numbers. It's probably 50-50 Victoria versus Vancouver. If you're familiar, they're right across the water from each other. And in fact, in some of my detailed discussion at Tech, I'm going to highlight companies and organizations out of that part of the world, kind of to thank you for having launched that, and because I was recently there visiting, so they're fresh on my mind. But again, big reach, lots of organization across the world. Individual members range from students, a life membership, and emeritus are sort of more senior folks. Patrons, it typically goes into more organizational. But the one I want to talk about here is ECOP. ECOP stands for Early Career Ocean Professional. And the definition we use there is if you are within 10 years of your last degree, that makes you an ECOP. So it doesn't matter how old you are. So you were 40 years old and went back to school and got a PhD in oceanography. You can be an ECOP in your 40s, right? It's not age-based. It's where are you in your career? And we picked 10 years because we really want to help people. And we realize networking, mentorship, growing your personal network, growing your skill set. We're all here on Zoom. This is great. But that individual relationship and stewardship of your career is a team exercise, or it can be a team exercise, and we try to do it that way. Mentioned organizational members. You see some pictures here from a trade show floor. So for example, if you think about a technology company that might build an ocean widget, that could be a large company. It could be a 10-person company. Here in New England, where I live, there are many sort of small companies like that. Oftentimes, those are some of our most active organizational members. And they really are great folks. They like to get involved with each other, they like to hear what the market needs. They like to share their new ideas. And I would also say that organizationally, we are building a very strong relationship with government, in particular with NOAA. I'll talk about that a little bit later. So members, and I'm winding down the sales pitch on MTS, but essentially members sign up to get value, and there's a journal and newsletters. We have committees and sections, and this is where I'll take a minute to explain. The sections I mentioned are regional groupings of people. So they'll often conduct activities like they'll have a monthly meeting. They might go to one of the companies, might be having an open house, and typically they'll get a guest lecture about the company, a factory tour, they'll have some beer and pizza and network. Committees are more focused on topical areas. And so one of my favorite stories about committees involves a technology called dynamic positioning. And this is how you hold the ship in place on a specific part of the ocean. Very, very important in things like drilling for oil and gas. And some years ago, our dynamic positioning committee was seen as an expert in the technology, and the U.S. Coast Guard was trying to consider rules around this technology. And the end result was our DP, Dynamic Positioning Committee, wrote a best practices document. And they wrote it in collaboration, industry players, government players, academic players. They wrote this document, and it's a living document. Again, it is not a rule. It is not a technical standard. It's just, like it says, it's a best practices document. And the Coast Guard elected to reference that, and it saved the Coast Guard a lot of work. The next place I'm looking to have such a thing done, and we're still trying to figure out whether it should be with our Offshore Energy Committee or our Ocean Robot Committee. There's a lot of interest in acoustic monitoring for offshore wind and the presence of marine mammals and things like that. And new technology can change that game. And we're hoping to collaborate with agencies and big industry providers to come up with a similar best practices document, so that the people who build technology, people who use technology, the people who buy technology can all approach that market with a common understanding. So that's what committees are all about. And then there's all kinds of online stuff, right? So I'm going to move on. There's going to be plenty of time for discussion. I'll pause there. That's my email and my MTS capacity. That's our website. Please feel free to reach out and follow up on MTS with any interest you may have. But I'm going to shift gears and talk about the cool stuff, right? Let's talk about the technology and what's going on. I'm going to touch on essentially two technology types, and then we're going to talk about a specific application and some of the big picture opportunities. And again, all of this is meant to compress a big ecosystem into a short period of time. So hopefully there can be a healthy Q&A. So robotics, platforms for access to the Arctic. Could talk about icebreakers, could talk about nuclear submarines popping up. We could talk about satellites. There's all kinds of tools. I'm going to tell you a little bit about what's going on in robotics. And the reason for that is, generally speaking, ocean robots are becoming more capable. They're becoming more affordable. And as they become more capable and affordable, they open new approaches to thinking about how we solve certain problems in specific environments. And again, we'll touch on an Arctic idea for you. Sensors, likewise. Historically, the development of ocean sensors, a big influencer was the Cold War, and in particular, the need to understand oceanography for anti-submarine warfare. So therefore, we got really, really good at measuring salinity, temperature, and depth, because those parameters shape how sound moves through the water. And that therefore changes how you can listen for activity underwater. Only recently have other disciplines like biology and chemistry started to benefit from electronics and digitization and things like that. So there's a lot of new sensor types coming on board. We'll talk about that. The real application set, you can bin this in different ways, but classically there's security, there's science, and there's commerce or industrial activity. And the example I'm going to use touches on all. And then technology transfer, collaboration. How do you take these diverse stakeholder sets, diverse problem sets, and get things done? I'm going to give you some concrete ideas that may be relevant to your work. So robotics, we're going to go into a little detail about these, but there's three basic categories. UUVs, uncrewed undersea vehicles. So that's a submarine with no people, goes underwater. USVs, uncrewed surface vehicles. That's a boat, goes on the water, no people. UAS, uncrewed aerial systems, often referred to as drones, they're a whole nother approach. And I got some good examples of all of these here to tell you about. Again, all happen to come from the Pacific Northwest, British Columbia. So a company to reference called International Submarine Engineering. Sorry, I didn't feel appropriate downloading this video off YouTube. You can go track that link down at your leisure. It's kind of a long video, and it tells you the story of what you see in the top left. This is an underwater vehicle called Theseus. And in the bottom right, you can sort of get a sense of scale. There's some small vehicles, there's a person, there's a workshop, and there's a really big underwater robot. And in 1996, like, think about that. Almost 30 years ago now, that robot was put under Arctic ice. And if I remember right, it basically swam under the water, and it spooled out a fiber optic cable behind it. And this was to create a data connection between science camps in the Arctic. And I think the statistic was 167 kilometers. So this robot went 167 kilometers under ice, laying a cable to connect two things that are on different sides of Arctic ice. And if you can go watch this YouTube video, it's a little dramatic and it's grainy because, again, almost 30 years ago. But that's a really important example to tell you that if you want to put robots under ice and in Arctic environments, it's absolutely doable, right? It's been there, done that. Doesn't make it cheap. That was not an easy job, and it certainly wasn't a cheap job, but it can be done. So just one example of how this tech can apply in that environment. Here, this company, happy to share their video. They're a startup. They're called Open Ocean Robotics. I show you this video to show you kind of how amazing it is. You can build a robot. This little robot boat is going and doing these barrel rolls and flipping over the surf. It's perfectly happy. It's solar powered. And so we're going to talk a little bit in my use case as to why I think that's relevant. This company also happens to be in British Columbia, and they benefited from a fair amount of Canadian public sector support. Sidebar, this is the kind of robot I started building 30 years ago. And when I built little robot boats, I couldn't make it across the Charles River in Boston, let alone survive in conditions like this. So definitely cool tech. Another cool piece of tech, I'm going to make this video play, from a company called Seahawk Robotics. Drone, great, looks like a drone. We've seen a drone. But what you're going to see is this drone is now going to go out and land on the water. And we've got other variants of this drone that use a winch, and we can lower a payload from inside the drone into the water. And so why this matters is, you think about it, like you could hover and dip something in the water, but you're using immense amounts of energy just to hover. The drone can land, turn off its engines, put a sensor in the water, collect some data, maybe even collect data for half an hour, take off, move, do it again, right? So this is a whole new approach to getting you into inaccessible environments much more affordably than you might with other solutions. This company also, this is a Vancouver-based company, very small, nascent startup, just getting going. I happen to advise both of these robot companies, mostly as a volunteer on the side. So these are 3 examples of ocean tech innovation that is applicable in the Arctic. So let's talk about sensors. Again, all of these, any one of these subjects could be hours of content. Basically, there are 3 trends in sensors that I think are worth thinking about. So acoustics, we alluded to the Cold War drove oceanography to help us shape anti-submarine warfare. That's acoustics. You see World War II submarine videos and the notorious sound of the ping, right? So we all sort of have an intuitive sense, perhaps, that sound underwater is a powerful tool. What's happening today is driven by things like smartphone technology, processing, machine learning. We're extracting a lot more value from acoustics in the modern digital era than we did in the old school era with, somebody with headphones on, maybe looking at a very grainy display. And the photo in the top left is a product called the Hydromoth. And essentially, you could think of this, if you're sort of familiar with GoPro cameras, right? Like they're relatively affordable, they're robust, you strap it onto your bike, you strap it onto your surfboard. Same idea, except it records sound. And we're getting these down. This is work I do with my philanthropy client. We're getting these down to the point where, that's a sub $100 item, and it can store a whole bunch of acoustic data, and then you can plug it in and you can run it through all kinds of open source acoustic algorithms and figure out, were there fish there? Were there whales there? Right? So it's really opening up a much wider spectrum of being able to listen to the ocean environment, because the tool is becoming dirt cheap. And even though acoustic data produces volumes and volumes of data, the digital technology to analyze that data is becoming easier and easier to use. So that's one trend line in sensors. The next one, and this next over is, this is a sampling device made by a company called Dartmouth Ocean Technologies. They're one of several who are working to do this, but it's called eDNA, environmental DNA. And essentially the idea here is that every living organism, when it's in the water, is shedding some of its DNA. So for example, if I went swimming in my local pond here on Cape Cod, and one of these samplers were put in that pond, and it had the right kind of sample targets, it could collect the water samples. And if they knew my DNA signature, they could run through it and validate whether I'd been in the water or not. At the very least, they could validate whether a human being had been in the water, or a turtle, or a whale, right? Right now, this technology is based on collecting samples, bringing the samples back, and doing the analytical work on lab. Where it's moving is we will get to the point where, let's say you're interested in the eDNA signature of the North Atlantic right whale. In the not too distant future, we'll be able to teach the instrument with the right analytics and the right the chemical analyzer reagents on board. Essentially, it'll have an electronic indicator. It'll just run the sample, like, yep, there's northern right whale DNA here right now. That's really cool. We've never been able to do that before. Really important comment on eDNA. If in that example, we saw that there was a northern right whale wherever we put that piece of technology, that eDNA signature lingers for possibly a week. And we have no idea whether it was one whale or 100. So right now, eDNA is a great tool to identify within a short period of time that there's been the presence of an organism. So important caveat, but really cool tech. Last piece of technology I want to talk about relates to the carbon cycle in the ocean, right? So climate change is prevalent. We can't get away from it. There are a lot of folks who believe the ocean will help us remove carbon dioxide from the atmosphere, ranging from ocean alkalinity enhancement to sinking seaweed. There's all kinds of ways people are hoping to use the ocean to help remove carbon from the atmosphere. However, to make that work, we're going to need to build very, very robust models and very large temporal and spatial scaling monitoring networks of the actual carbon cycle in the ocean. So the idea is eventually you're going to be able to buy a carbon credit, but you're only going to buy that carbon credit if you trust that the methodology is actually sequestering the carbon. And they talk about 1,000-year carbon credit. So we need a lot of sensing capability. We need better sensors, and we need a lot more sensors. So the photos I'm showing you here is an oceanographic instrument coming out of Woods Hole Oceanographic Institution that senses methane, and it measures it right there in real time, and it can tell you how much methane is there. Why does this matter? Well, we know methane is a potent greenhouse gas. We also know that people are going to start doing things like sequester CO2 in liquid form in existing reservoirs that were once held oil, right? So we're now moving the methane sensor to a CO2 sensor, so we can start to do things like monitor for signature changes in these important carbon chemicals in the environment. So lots of cool things going on in sensors, the really rapid progress. So what might we do? So I just dumped a ton of thoughts on you about technology in the ocean. The specific problem I'd like to talk about is we often refer to as MDA, Maritime Domain Awareness. And what I like about MDA is it's relevant to all stakeholders. If you're a scientist, you want to know what's going on out on the water. You want to know, was there a whale spout? You want to know, did a cargo ship sail by at such and such a time? Did we hear dolphins swimming? Did we detect whatever organism you care about or whatever chemical or biological signature you care about? Industry needs to understand maritime domain awareness because it's a combination. Think about, you go and you got to go on a long drive and you look at your Google map to check travel conditions. Oh, and you also check the weather, right? So commerce has the same concerns in the maritime environment, and MDA generally helps answer them. So this is again, I opened earlier about how I spend a lot of my time, I call it talking about profit in planning, right? So I operate under this thesis that technology that can stand alone in a free market that also provides a conservation benefit is a positive cycle, right? Because people will buy it, it will have benefit, it will, as opposed to one-off technologies that don't have any market value but have conservation value, it's harder for those to get uptick. So maritime domain awareness is one of these things. And bear with me because big slide, lots of pictures, what's going on here? Let's think about the Northwest Passage, right? So what's going on in the Northwest Passage? Bottom right, there are obviously defense interests in the Arctic. Canada cares about this, the US cares about this, neighbors on the other side of the North Pole care about this. So maritime domain awareness, huge, obvious defense implication. Biology, right? So, whales, creatures, native fishing grounds, so many biological things going on up there. And then there's this commerce question, right? So as ice recedes, there's strong interest in sending cargo vessels, and there have already been cruise vessels running around up there. And the cruise industry, they don't advertise it this way, but people pay attention. They're like, look, cruise ship going through the Northwest Passage is still a bit dicey, right? Because there's not a lot of rescue resources. There's not a lot of, nearby radars or monitoring networks, right? So there's a fair bit of uncertainty still. And so we got all of these needs. What might we do? Well, imagine, if you will, and again, I'm not advocating for this specific project. This is a thought exercise because these are all companies I work with and I know and I'm friends with, So disclaimer aside, so let's say we took this solar powered robot boat that you saw flipping in the waves. It's robust. When does the Northwest Passage open? In summer. What happens in the Arctic in summer? Lots of sunlight, right? Great fit for a solar powered robot boat. This solar-powered robot boat could carry eDNA detectors. It could carry acoustic listening devices. Might even become a home base for one of these drones. Sidebar, the drone picture you see there is one with the hydrophone deployed. That same winch could tether it to that robot boat. So now this robot boat can have an eye in the sky. It can carry thermal cameras, which again, in an Arctic environment, that really helps certain things stand out. It can carry acoustic listening devices. You could easily envision maybe 10 of these, maybe 20 of these. By the way, even outfitted with all this gear, call it a $250,000 proposition. So let's say putting a network of 10 of these out, capital cost is $3 million. Operating cost for the season is maybe $1 million. So for $4 million with today's tech, you could have 10 high-powered mobile monitoring nodes moving around the Northwest Passage, collecting whatever data you want. Where are the chunks of ice? Where are the whales? Where are the bad guys? So that's the kind of case study, and I'm unaware of anybody proposing this or chasing that funding or promoting that model. And don't hold me to those numbers, but they're a good rule of thumb smearing around rough order of magnitude. So this is the kind of idea of what we can do with current tech and some creativity that changes the game. And again, I just picked the Northwest Passage and I just picked this application. Obviously, we could go on and on about others. So the last thing I'll talk to a little bit, right? If you're excited about that vision, how might this community come together? Tech transfer and getting technologies like this to market in the US, we've got some great programs. There's some Canadian programs as well. I didn't list here, but the SBIR program is a really powerful program in the US. I've worked with that program when I was in NOAA. I was on I proposed topics and I supported projects. Today, the companies I work with write proposals. The Navy, DoD uses SBIR very methodically. NOAA uses it differently. I don't know how other agencies do it, but to the extent we could get like-minded agencies who have SBIR funds to collaborate, that might be really interesting. Great segue. There's an activity called the National Ocean Partnership Program. If you're not familiar with it, essentially what it does is it allows agencies who are participants to pool their funds and issue a single, essentially RFP, and collectively support the same kind of work, but they can do it through one administrative mechanism. It's a very powerful tool. In my day job supporting philanthropy, we're very interested to try to explore with all of their, with appropriate recognition of government rules, we're not in policy, we'd love to see if we could bring private sector philanthropy funds into that same pot and work alongside government agencies. So another thing going on, if you may have seen a fair amount of press, NOAA is currently accepting proposals for what they call climate accelerators. These are funded by the Inflation Reduction Act, and they're a really interesting new idea. NOAA is actually going to start getting its hands into innovation and entrepreneurship and driving tech to support climate challenges. Obviously, Arctic climate, lots of potential challenges. Comment for you here, I mentioned MTS. So you mentioned the industry dialogues. We are currently anticipating, no promises, but we are anticipating launching a expansion of those industry dialogues. So that was done in collaboration with NOAA, NASA, some other entities. So we're hoping that as NOAA launches these climate accelerators, we're going to be alongside with an expansion of those industry dialogues so that we can engage that activity very rapidly with our members, agencies, folks like yourselves, and your peers and colleagues. Last comment, university and/or agency tech transfer is a notoriously hard thing to do. Universities, just as much as they desperately want to be good at it, they're not entirely great at it. But the new trend I'm seeing, and a great example out of the Woods Hole Oceanographic Institution, is a new venture capital fund called Propeller. So the VCs formally aligned with Woods Hole. So now you've got professional commercialization people working alongside science and technology development people trying to drive products to market. So I think we're going to see more coming out of that. My last comment in terms of addressing Arctic, partnerships are great. US and Canada clearly need to collaborate. I'm not saying we're not collaborating well. I know a lot of various agency collaboration already happens. but certainly in my MTS hat again now, right? Our big conference next year in Halifax, Nova Scotia. We've run it in Vancouver, so we're happy to be part of a convening mechanism. Government and industry, obviously, plus science and industry, continuing to get those stakeholders tied together. So, I just rattled on and on and on again. This is the exact same slide I paused in the middle. I'm going to stop. I've been talking at you. I really would like to talk with you and help you understand or illuminate anything I've brought up here. So if that's fair game, questions are open, but I'll defer to your moderating practices.
Thanks, Justin. That was a very insightful and informative presentation. I think one of the questions we have is how to focus IARPC tech team and meetings that we hope to host in the future, bringing in the private sector perspective, how to engage with them. I think what I'm also familiar with the marine realm, so I'm totally aware of these emerging sensors that you talked about. I was just a little surprised. I guess there's a lot of other technology that's, maybe not cutting edge, but could be applied in the Arctic. For example, the environmental studies program, we had a post or a CMI, the cooperative agreement with the University of Alaska in Fairbanks. They had a project where they were putting sensors on ice, and so it was some sort of tracking activity, and that was an innovative application of an existing technology. So it wasn't always about moving the sensors to, what beyond what they're doing now to do new things, but really thinking about how can you apply the existing technology to the problems unique to the Arctic. And I wonder if you have any thoughts on that, like especially around observing ice. I mean, that seems to be, for this ship, this autonomous ship, that seems to be one of the things you'd want to measure with that.
Yeah, well, and so
or whatever.
I did absolutely fair point. I focused here on what I would say are the emerging technology areas. And my interest in doing so was to get to that little hypothetical use case to say new tech might let us do a lot of things we thought was impossible. Existing tech can as well. So specific to observing ice, the probably, off the top of my head, the most interesting thing to do would be to develop what I'd call a system of systems approach. So obviously remote sensing is a powerful tool, and remote sensing, typically from satellites, though also from aircraft, is becoming much more capable, right? Particularly with our ability to really dig in and process the data better, right? So there could be a whole machine learning, historical data work, like some data scientist type person probably could spend a year doing amazing work with existing data and figuring out how to use existing remote sensing better. Roll into that, say, I think acoustics is another interesting one, right? So in fact, I'm working on a side project right now about directional sound sensors, and the idea that we probably are at the point where we could start to listen to the ocean, and what has often been referred to as noise might start to become signal, right? So in the Arctic, with ice and movement and noise, our ability, and again, you might use conventional buoys for this, for example. You don't have to use fancy flying drones to carry these hydrophones, but just listening for a season with proper digital techniques, we might start to be able to understand, and combine with remote sensing, we might learn a whole bunch about dynamics of the environment. Not to mention appearance of man-made, vessels and signals and things like that. So those are ways that I think you could certainly see approaching that. And then at the same time, you could, use, say, that robot boat and go get that last little bit of in situ data, whether it's a video of a particular piece of ice or it's a validation of a particular measurement, and you could create some very powerful modeling analytical capabilities, right? So again, mostly existing, but employing the existing tech now in a new systematic way linked to the power of, sorry, it's just algorithms. And I refuse to say AI because I don't know that the ocean space really has the data sets yet to teach AI, but we certainly can do what I would call machine learning or big data analytics. And, smart people can derive the insights, and then we can go from there. So long-winded way of answering your question. Yes, existing tech has a place to play. My key recommendation is system of systems approach, right, is important. And I think often missing, because a lot of times you'll get one agency flies a satellite and doesn't always think about what some other group might do. Or US might do one thing and Canada might do another, right? So anyway, I'll pause there. That's a lot of answer to a very fair question.
Yeah, just to follow up on that, my background's in data management, and IARPC has another foundational team for data, and we're trying to negotiate what's the boundary between tech and data. And honestly,
Yep.
we haven't had a chance to hash that out with them yet. So I think that distinction is, if you're applying existing technology but analyzing it in a new way, then that could be a tech focus.
Mhm.
A lot of these things that are, big data, AI, they might actually belong in the data realm because those are just ways you analyze data. But as long as it's tied to a sensor package and that's the enabling thing, then
Yep.
the way we analyze it's really part of the tech approach.
Yeah, I mean, a problem you have with that, I don't envy you. So think about that robot boat, for example. If that robot boat is sailing around the Northwest Passage, and let's say its primary job is to look out for ice with its cameras, right? But it happens to be collecting weather data along the way, right? And now one output of the boat is where is the ice, but a different output of the boat feeds into some weather model, right? And then is where does the difference between data and analytical product, right? Output. At the end of the day, nobody needs data. We need information, which is derived from data. So, which leads you back into technology and analysis. So it's, you are asking a great question. The industry crowd I hang out with, we've got startup companies who want to live on one side of the fence and some want to live on the other side of the fence. And I tell all of them, you better be willing to jump the fence and follow the money. Otherwise, you're going to get stuck on the wrong side if you guess wrong.
Great. Yeah, I think the idea of using video for sea ice detection is a cool one. So, do we have questions from the room? You can type them in and I can read them. I'm monitoring this chat, so let me see if we got one already. Anybody want to speak up?
Lisa, your hand went up there, it looks like.
It did, Jonathan. I think I'm just going to speak my question. It might be kind
All
of
right.
long to type. I was just looking through the different sections the MTS has, and
Yeah.
I'm going to drop the link for that in the chat just for anyone else. And it's just interesting to scroll through and see all of the different sections. Like there's one for the Great Lakes region, there's one for the Puget Sound. It makes sense to me that there would be one for the Arctic, or even the Arctic and Antarctic combined, since we have similar issues with technology and cold and bandwidth and all sorts of things. So my question, well, questions plural, if there was kind of broad Arctic or Antarctic and Arctic community interest in starting a section specific to the poles in MTS, could you talk us through that process, and specifically
Totally.
what kind of leadership would be required? And does MTS provide any type of support like Zoom platforms? And how would we recruit members to a new section or advertise it?
Yeah, so so great question. I think where the concept of section disconnects from what you're asking. So sections are typically geographically based, and it has to do with the human beings who inhabit that region, as opposed to the issues of that region, right? So like here in New England, and in fact, I'll be very honest, like New England, we got this challenge of like north of Boston and south of Boston. And in one sense, like, so if you try to do networking north of Boston, south of Boston, people don't go, right? Because they hate the traffic, right? So like we try to sort of do every other month, right? North of Boston 1 month, south of Boston 1 month. So the only section we have that is thematically focused is ECOP, the Early Career Ocean Professionals. And that's just kind of a default you get put into it. It's really more of an online community where those early career people network with each other in a much more distributed way. We call that a section. But to address your question, the tool I might recommend would be a committee, right? So we have a committee on the ocean robots I talked about. We have a committee that I forget exactly what they're calling it, but essentially offshore wind is a thematic topic that's got lots of subtopics, and we've got a committee gathering. So for a gathering of human beings who care about marine technology issues in the Arctic or the Antarctic, or just in high latitudes or just under ice, like we could definitely empower a committee. The way that works is, and this is generally true of committees and sections, but sections requires a leadership group, typically 4 named officers, but the titles are irrelevant. Basically 4 volunteer leaders, and then 15 members within that region in good standing have to sign a petition and say, we're organizing ourselves. Committees, it's not quite the same. Typically with a new committee, you would get an individual who would end up being the chair of the committee. They'd probably get 2 to 4 other people who care. They would come talk to our oversight committee, 4 committees at the board level. We'd say, yeah, okay, if you write us a little plan and a structure and give us a list of the 20 people who are going to join the committee, it's pretty organic. And we have people, paid staff members, to support those committees to help them get started. And yeah, so there's definitely staff support available, but it is very much, it's a little bit of you get in what you get out what you put in kind of situation. There is an opportunity for you to engage in a network in a community, but it does take a little bit of volunteer effort to impart the momentum and get the system running. But yes, I'd be happy offline. You can shoot me an email. We can talk about that. And I mentioned this Ocean Enterprise Initiative, which is sort of this expansion of those industry dialogues. We are looking at strong relationships with government agencies there. So if this is of interest to you all, I think we might be able to do something like sponsor. We have a brand name, we call it a tech surge. So like a one-day workshop. So we might be able from headquarters to help you launch a committee by running, say, a one-day workshop on certain issues, right? And we could bring, and then what we do is we'd be advertising to, say, our corporate members, hey, do you have this technology, that technology, or that technology? Or do you have this market problem? And the Arctic Committee is launching a tech surge, and we'd help you find speakers and run panels and then publicize the output. Those are all well within the bounds of how MTS would work. Again, long answer to a great question. Hopefully that was sufficiently clear.
Yeah, I have a question that brings it back to something you brought up in the presentation. And I think you were talking about government academic technology transfer. And something I didn't, we had a presentation before from a USGS policy chief talking about the technology transfer acts and so on. But one thing I didn't understand is why, what's the barrier right now for us to do technology transfer through academic and federal agencies from your perspective, and how can we do that better?
Yeah, so there's academia and agencies are pretty distinct in this problem set. So academia, a few universities have gotten pretty good at this. But, it typically involves a couple of factors. And technology, IP is developed at a university. University usually has the rights to that, you know, even if it was funded by NSF or NOAA or Navy, right? So step one is the owner, the university, has to come to terms with some user, typically a company, startup company, or sometimes a big commercial company, on the value of that IP in a licensing structure. And the classic problem is that universities often believe their IP is the most valuable thing on the planet. And the market reality is you don't know that right away, right? So interesting approaches to licensing whereby, you know, maybe the university doesn't get its payback until it turns out to be the next big thing, right? Maybe the university lets a lot of IP go apparently for free because most of it's going to fail in the market, but then those few that hit big compensate it later. So universities struggle with that. The other thing that often is a challenge in universities is the people who understand the technology best are usually professors who run labs, graduate students getting PhDs. It's fairly rare for those people's cultural instincts to go off and start a company, right? And so another thing we can be working on, and by the way, the NOAA climate accelerators, I'm hoping contribute to this problem. I'm hoping that they're actively connecting those people to entrepreneurs, because the best thing is a founding CEO who partners with the scientist. And the scientist can come on board as, there's this term, chief science officer, right? So the scientist doesn't have to give up their job, but they have to share their brain power with an entrepreneur who wants to make a company, right? Those are great things to happen. Agencies are now very, very different. The ones that I think about are places like the national labs, right? So, PMEL, for example, I know well, they developed an ocean CO2 measuring system that we put on the wave glider to measure CO2 flux. Eventually, I got licensed to Battelle, which happens to be a company that runs labs for Department of Energy, PNNL. But that structure is actually pretty good. And there, I think the opportunity is for a community of practitioners, and MTS is happy to be part of this, to make sure that people know what's coming out of those labs and understand the connection to a market demand. So in that case, that sensor, which was for measuring carbon flux between the ocean and the atmosphere, it was sort of ahead of its time. Like now, when I talk about ocean carbon cycle, that tech is pretty interesting. Back when Battelle licensed it, they didn't get the market uptake they were hoping for, and so it didn't take off. But that's okay. Like we might revive it. So anyway, long-winded answer, but it comes down to human beings need to be willing to talk to each other and find creative paths to collaboration, recognizing that the cultures in all these places are different.
Yeah, and I think that to our team, it speaks to a need to create a space where people from different sectors can come and share sales pitches or whatever it might be, because these are opportunities. And it's not to say, that we have to be flush and be able to afford to take the technology and run with it. But unless we create that space, these opportunities might be lost.
Yep. And again, and I'm conscious of time, and I'm going to have a hard stop in 2 minutes myself. But I just leave you with that. Personally, in my day job, I employ a practice which I call karmic networking, right? Which is I'll give away everything I know for as long as it takes, because it always works, right? So feel free to reach out, ask questions. And on behalf of my colleagues at MTS, I'm a volunteer. The paid staff, I protect their time. But I'm always happy to feed them opportunities to do good work for the organization. So in both capacities, I'm available at your service and really, really interested in being collaborative around this. It's an important topic. All of these are important topics, and I'm excited to help.
Well,
go back to full screen mode so you can see me big.
Great. Yeah, thank you so much. I think we have less than a minute, so I just want to take this time to thank you, Justin, so much for presenting to us and giving us some direction for the technology team and moving forward. Thank you so much. Anybody else want to say thank you to Justin before we leave?
Yeah, just thanks, Justin. It was very informative.
My pleasure.
Okay. Thanks so much, everybody. Catch you later.